So as I was saying, this is a continuation of our intermediate value theorem from last night. Anytime you want to prove anything using the intermediate value theorem, before you start doing anything, you have to show that the intermediate value theorem actually applies.
Okay.
So the first step, and I'm going to go ahead and put this first problem up, and I will go through it some more, but I want to use this first part to write the values down. So the
Okay.
first condition to using the intermediate value theorem, if I'm talking about a composition of functions, okay, then the function I swallow has to be continuous. Here F swallows G, right?
Right.
And if the function I swallow is continuous, I also have to show that F is continuous. The result that comes out of it. Because the result that comes out of F of G of X also has to be continuous. That was given to you. It says the functions F and G are continuous. Now, if this happens to be a function that doesn't tell you that, then you have to show that or have it some other way where you can know that that's true. So what I'm going to do now is take a minute off screen and write the table down. So 104,296. Now the other thing that's going to come up here is, do you know how to get the composition of functions from a table like this? Not hard, but it might not be immediately obvious. 4, 3, 1. We know how to read f of x, right? So, for example, what is f of 1?
0.
Right. What is g of 1?
4.
So what is f of g of 1?
F of G. Okay, wait. F of G
So
of
start
1.
with.
So it's -3.
Okay, so you start with g of 1, which is 4. Then you go f of 4, so you go to 4.
Yep.
And you read okay, so you do know how to do that. Very good. I just want to make sure, because that's another whole concept in and of itself. All right. So let me go ahead now and do something here. I'm going to, it says explain, so I'm going to write explain why there must be a value in the interval such that h of c is -2. H of c is -2. Okay, so here, all right. So this is a little bit different. A couple of reasons why. Let me put up the whiteboard here. And I'm gonna make a drawing. I'm gonna cheat and use one of the rectangles here. I'm gonna use a rectangle for this grid right there. And then I'm gonna cheat again and use a couple of lines here. And we're just I'm gonna reproduce the table that's there so we can see what we're doing. So here's my table, right? And I've got that. And I got a bunch, I got 6 more lines I gotta do. So 1, 2, 3, 4, 5, 6. Not perfect, but well, that's okay. We're gonna do text. We're gonna do 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. And then we're gonna do, oh, it only went to 5. That's all right. This was X. This was f of X. And this was g of X. G of X. So now we have, what do we have here? 0, 9, 7, 0, 9, 7, -3, and 8. Oops. Skipped 1. -3 and 8. Okay. And then the G's are 4, 6, 4, 6, -4, 1, and 3. Okay. So we're given that H is H of X is equal to f of X, f of g of X minus X. What we're given. And we want to find this value. So the first step, as I said, is to always demonstrate that the IVT applies before actually using it. Okay. Now, there are 2 conditions. Okay.
Okay.
The function must be continuous on the closed interval. Okay, so we have to be continuous, right? And we saw from last night that there has to be, I'm going to write this another way than the theorem actually does, but there has to be a sign change on either side of some value that they're talking about. Some value, either 0 or 4 or whatever, right? There has to, so now the difference here, this, all of that is the same. We haven't done anything different. The difference in this homework is that you're working with compositions of functions.
Got it. Okay.
So the rules don't change. It's just, how do I show that if a composed function is continuous? I'm gonna stop sharing this for a minute. And I'm gonna talk about the continuity of composed or composite function, because it's a little bit, and again, this is a theorem, and it comes from algebra, okay? That how do you actually show that you have continuity of composed functions, okay? How do I know when they're continuous? Well,
Shauna, are you supposed to be sharing your screen right now? Or
no, I'm looking
oh,
for
okay.
something.
Sorry, I just wanted to
No,
ask.
I'm trying to see if they actually tell you something about, let's see, I'm trying to find a decent explanation of this. Okay.
Okay.
Because I think this is a bunch of proofs, right. So let's see. Okay, so here's the theorem. I'm gonna just show you this theorem, and I'm sure she probably did too. I'm gonna show it to you so that you know it's a theorem, because I don't see it anywhere on here. And I want to make sure you know that there's a theorem that says this. We're not going to prove it. This whole document has a whole bunch of continuity proofs with a bunch of, we don't need that. What we do need is this continuity and composition here. So we need this thing here where it says theorem 9.3, which don't worry about the number, but it says if G is continuous at A. Now, why did we start with G? G is what you're swallowing. G is the inner function. So if my inner function is continuous at some value A, and F, the outside function, is continuous at the output from G of A, right? In other words, you evaluate G of A, right?
Yes.
And you plug that output into F, right?
Okay.
If F is continuous at the output of the inner function, then the composition is continuous at A.
Okay.
Okay, that's actually what this is saying. So when we go back to this here, F and G are continuous already. Well, that's helpful. But since F and G are continuous, G at, in this case, G at my value is going to be continuous, whatever it is, right? Because G is continuous everywhere. And if G is continuous everywhere and F is continuous everywhere, we don't care what it swallows. The composition is going to be continuous.
Got it. Okay. Yeah.
I just wanted you to be aware that it's slightly different. The theorem is slightly different. That's how we know that the composition is continuous, right? So that's this first condition here. F and G are continuous, and that makes the composition continuous, right? Now what we have to do, we have this interval, we discussed this last night. we have this interval from 1 to 5, right?
Mm-hmm.
Hence the table right here, yeah?
Yeah.
So remember h, because h is this composed function, h at 1 means we have to evaluate f of g of 1 minus 1, okay?
Got
Which
it. Okay.
he has here for you, right? When
Mm-hmm.
you evaluate a composed function, start from the inside, g of 1, so go to g, which is this line here, okay?
Yep.
Your x is this x. G of 1 is 4.
Got it. Okay.
G of 1, this piece here, is this 4 here.
Oh, okay. Okay.
G of 1, so let's do that again. G here of 1 is 4. G of 1 is
Okay.
4. F of G of 1, so F is swallowing whatever G of 1 is.
Mm-hmm.
What is G of 1? That's 4. F here is swallowing 4. So F swallows 4. What is the result?
-3.
-3. That's this. Where does she get -4 from? Because this is -3 minus 1.
Got it. Okay.
Why 1? Because x, remember it's f of, because my function is f of g of x minus x. And
Got it.
x
Okay.
is 1, right? So
Mm-hmm.
-4. Now we've got to do the same thing at the other end. Remember, you have to check both endpoints. So we have h of 5, f of g of 5 minus 5. So g of 5, so we go g of 5. So here's g of 5 is 3. This result here is 3. F swallows 3, so F, 3 there, F. F of 3, F of 3 is 7.
Okay.
So this becomes 7 minus 5 is equal to 2, right?
Got it.
That's
Okay.
where she got that from. Now, h of 1, we don't know what this function looks like. I mean, we could graph them all, but we really don't know what this looks like, right? But we do know, picking up from some of the last exercises last night, that h of 1 is negative, h
Mm-hmm.
of 5 is positive, right? Since there's a sign change, one is negative, one is positive, right?
Mm-hmm.
Must be a value between -1 and 5 for which h is -2. Why is that? Now notice it didn't say 0, did it?
No, it didn't.
Not here. It says -2. This is between -4 and 2. So what this is basically saying is that whatever this function looks like, whatever h looks like, remember we're looking at the outputs, right?
Mm-hmm.
So we're looking at, there's -4 and +2, right? We're looking for -2, right? So this is going to be -1, -2, and so on, right?
Right.
So we want to know where this happens. Well, we've got one that's down here and one that's up there, right? So it's going to hit at some point. We don't know where. But if in this value, it went from -4 down here. So let me get a thicker dot. Let me see. Thicker line. Okay. It went from -4 right here to whatever that value was that I had. -4 and -4 and 2, right?
Right.
So this is going to be -4. This is going to be 2. We don't know where this occurred. We don't care. But there's a value for which that's equal to 2 now, right?
Got it. Yeah.
So there must be a point. Remember here, they're asking you about -2. So what they're asking you is to go from where we were last night. This is where my line would be.
Okay.
This is my -2, right? And I don't know what my function does between these 2 points.
Right.
I don't know what it does. But I do know that it's continuous. Right?
Okay.
So what I want to know is there a value where it hits -2? Didn't ask me to find it this time. I don't have enough
Okay.
information to find it. But by the intermediate value theorem, I can tell you there has to be one. There has to be a value, right? Because if there weren't, it wouldn't be a continuous function, you see?
Yeah.
Now this graph, you don't have to draw. This is just kind of a visual, but that's, we know it's continuous. We saw the sign change in the composition. So therefore, the thing is that the line here, the level that you're choosing, right, has to be a y coordinate between these two y's.
Got it. Okay.
Okay, and it is. So that's why that works the way that it works. It's not all that hard. It's just hard to wrap your mind around it. Okay.
Yeah, there's a lot.
Looking at number 10, so given f of x is equal to x over x minus 3. F of x is equal to x over x minus 3 on the interval from -2 to 2. Okay. Determine if the IVT applies. State why or why not. Then find the value of c such that f of c is a third. Okay.
Okay.
All right. So I'm gonna.
Isn't there a restriction here, Shauna?
There is a domain restriction. Yes.
Okay.
There
I
is
don't.
a
Is it?
domain. There is a
Yeah. Will it
domain
affect us?
restriction. What was that?
Will it affect the I don't know, the graph? I mean, not the graph, but
Okay.
like.
That's an excellent question. That is an excellent question. And the answer to okay, so that is an excellent question. So we have to think about something here. So let me answer. You've got about 3 questions in there that are
Sorry.
no, they're all excellent, and you should ask them all. Okay, because it's nothing to be sorry about. It's excellent critical thinking. Here's how you think about this. I'm going to go ahead and do this problem for you.
Okay.
Okay, from
Okay.
scratch. I'm going to go ahead and do it from scratch, and I'm going to see if you can follow, because now I think you understand enough of the theorem to actually, I think you can probably track pretty well.
Okay, cool.
I think it should be, I'm hoping. We'll see. If not, we'll just go over it until it gets better. But I'm hoping that that we picked up enough last night to be a little better for ourselves, because last night started out rough, came back strong, but started out a little rough around the edges when we were doing it. So let's see. Help you with
It's
that.
not because, like you said, it's not hard. It's just there's certain parts that are kind of just difficult to like grasp.
No, and
once you get it,
it's abstract. It's abstract is what it is. So here's what we want to do. I'm gonna make sure that I'm sharing the Desmos screen here. And I'm also going to come back, do one thing before I do that, and that is save the whiteboards, because I don't want to lose them if we happen to lose the Zoom. So, okay, we're going to tackle this and we're going to see what's going on. So remember, and I told you, whenever you're doing an intermediate value theorem problem, you have to see if the conditions apply first, okay? So here we have a function, and I'm going to use y rather than f of x, because Desmos likes y's. X minus 3. There it is. Now, do we have a domain restriction here?
yeah, there's an asymptote.
We do. Where is my domain restriction here?
At 3.
That's right. So there's a restriction on the domain at x equals 3, right?
All right.
Now, I'm going to go ahead and draw that in just for clarity, all right? I'm going to draw that in, and I'm going to make it a dotted line if I can. Come on, line. It likes to do this. Okay, there we go. I'd like to make it dotted. There we are. There's my graph, okay? Now, that is important. However, what interval are we on? Do you remember?
No, I forgot what interval it was.
Okay, so the interval that we're given, is the interval from -2 to 2. Okay. Now, when you read the conditions for the intermediate value theorem, and this is important because this is where your first, not confusion, but this is where your first point came in. I'm gonna pull up something else here for a minute. Let me see if I can find it. 1.8. Yeah, I want to show you this theorem again. This is from last night. And I want to show you the intermediate value theorem here, okay? So let me put it up on the screen here. And I'm going to take a screenshot of this slide for you and send it to you with the notes from today. A function f of x, which is our x over x minus 3, that is continuous where?
On a closed interval.
On a closed interval from a to b. Does the function have to be continuous everywhere for this to work?
No.
No, it doesn't. It only has to be continuous on the interval that you're talking about.
Okay.
So we can have other break. It might have another break somewhere else, but it has to be continuous on the interval that you're talking about.
Got it. Okay.
Okay. So that should, in theory, let's see if it did. That should, in theory, answer your first question, which is, does this domain restriction matter? My asymptote is at 3, right? My interval given is from -2 to 2. So am I going to have a problem here?
No.
No. So here's why. I can say this. The function f of x is continuous on the given interval from -2 to 2, right? Since, I'm going to just write this comment. Since x equals 3 is not within the interval, right? If it were, then we'd have a discontinuity on the interval, okay? So it's continuous. So that's the first condition, right? The second part of this condition says that we have to have a sign change at the values, right?
Right.
So it wants us to look at the interval, and here we have it, okay? Sometimes we don't have it, we have to work backwards like we did in the other problem. This one, we have the interval. So here's the second part. This is the second part. This is the second part of determining whether the IVT applies. We haven't actually applied it yet. This is the second part. So what we're going to do is we're going to evaluate the function, all right? So we're going to find, in this case, we're going to find y at -2. So we're going to say, I'm going to call this f. So I'm going to say f of -2. Now, what is f of -2?
Is that like 1 or is that like, wait, number -2? Oh, you can put it into the thing. That's
What is my function here? Remember?
it's x over x minus 3.
So -2, right?
-2
Over -2 minus 3 is what?
That is -5.
-2 minus 3 is -5, correct? So
So it's
this
2/5.
is -2 over -5, which is
2/5.
2/5. Okay, so we're there. That's 2/5, yeah?
Yes.
Now let's evaluate f of +2. So we're going to do f of +2. What is f of +2?
That is -2.
2 over 2 minus 3, yes. So this is going to be 2 over -1. And that's going to be -2, right? Now, just for a little more clarity about what this means, I'm going to plot a couple of more points on here. This is -2 and 2/5. And I'm going to go ahead and label that point right there, okay? They made it a decimal. That's the point in purple, right? And then we have another point, which is 2 and -2. So I'm going to plot the point 2 and -2, right?
Yes.
Like so. Now this point is in black down here, okay?
Uh-huh.
Now what I'm going to do, for the sake of doing what we did last night, is I'm going to draw, there's your points, right? We're
Yes.
trying to decide, so we can now say, what can we say here? We've seen what? We've seen a sign change, right? There's a value 0.4, there's a value -2. What are we evaluating? We're evaluating, we want to find out, is there a value where y is equal to 1/3? That's what we want to do.
Right. Okay.
We want to find, remember, it doesn't have to be 0. That's the sticky point sometimes. Sometimes students, when they start to figure this out, are like, okay, but I'm supposed to use 0 all the time. Not necessarily. I'm gonna put in a green line.
I have a question. Can they give you negative infinity? Or like positive infinity?
It has to be a closed interval, remember?
Okay. Right, okay.
Closed interval means they won't be infinite. The graph could
Got
be
it.
infinite, but it won't be infinite on the interval that you're on.
Okay, cool.
It's a closed interval, okay?
Makes me feel a lot better.
So here's my green line, right?
Right.
Now, what you want to figure out is this green line here, this level, okay? Is it, and remember, I should have graphed this, technically, I should have graphed this on the interval from, let me do that here. This is on the interval from -2 is less than equal to x, less than equal to 2, right? So we're not looking at the whole graph, we're looking at this here, right? Okay, so now, let me get this out of the way. There we go. Let me pull that back down. Okay, so we've got our function, right?
Yes.
Now, it's hard to see here, but that's why I have these labeled. Okay? This green line is y equals 1/3. This purple dot has a y of 0.4, okay? That purple dot is above the green line.
Yes.
2/5 is bigger than 1/3, so it's above the line, right?
Right.
-2 is substantially below this green line. So essentially, we have a sign change.
Got it.
Right? That's
Yes.
why she makes you do this that we just did. That's why we do these evaluations that we just did on the side. Okay?
Yeah, that makes sense. Yeah.
Now, after all that, okay, now we can say that something like this. And I don't think she writes this all out, but because the function is continuous on the interval,
She's been writing it out like that lately.
and a sign change occurs such that f of -2, and I'm just stating the facts here. F of -2, that was 2/5, right? F of -2 is greater than 1/3. And f of +2 is less than 1/3. The IVT guarantees a value C in the interval such that f of C equals 1/3, okay?
Okay.
Now, granted, that's a bit of overkill, okay? It is. But we've proven that the IVT applies.
Okay.
Right? Now
Yes.
we actually get to apply it. We haven't done it. We actually get to apply the IVT now, right? So what do we have to do? What are we trying to do here? There's a value in the interval here.
Right.
Where the function, the red curve,
Right.
is equal to the green line where they cross each other.
Right. So we're trying to find the y value.
Actually, we're trying to find, we know what the y value is. It's
Sorry, the x
1/3.
value.
Yeah,
Sorry,
we're trying to find
My
x.
bad.
Exactly.
Sorry.
Exactly. So what we're going to do is what?
Plug in 1/3 into.
Okay, where does 1/3 go? Look at your function. Where does it go?
It goes into x over x minus 3, right?
Right. So it goes. So what you're going to write is you're going to say this. You're going to say that 1/3 here is equal to x. Now I'm going to make a change in this in a minute, but first, x minus 3, right? Now there's nothing wrong with this essentially, but there is something slightly wrong with the format, okay? Because what did I tell you last night about these x's? That when we're using because this variable is supposed to be what now?
1/3.
It is, but what am I supposed to change the variable to? Remember, we don't want to get confused with our x's.
Oh, you can change it to c.
So we change them to c's. So we should write this. We should write 1/3 because we're looking for a value of c, aren't we?
Right.
So 1/3 should equal c over C minus 3. And then all the calculus is now over.
Mm-hmm.
Your calculus is now over. What am I gonna do now?
You're gonna plug in. Oh well, yeah, you're gonna plug in 1/3, right?
Do
Or
you
is
see
that
one?
what?
Do you
Oh,
see
it's
one?
1/3.
I
Oh, it's
plugged it in
1/3
already,
equals.
right? I
Okay, to the
plugged it
y.
in for
Okay.
Y here.
I keep forgetting that it's a y. I keep forgetting it's y, not x or c.
Because it's F of C. F of
Right.
C. So F
Okay.
of C means I put a C everywhere here. And F of C, which is this
Right.
function here.
Yeah,
So
I
let's
keep forgetting that.
F of C. F of C is C over C minus 3. That's this.
Okay.
So F of C, this, let me write it below it. This is F of C. This is what you get when you plug C into that function up here, okay? You plug C into this, you get F of C. And F of C is supposed to equal 1/3, right?
Got it. Okay. Yeah,
Now,
I keep forgetting that. Sorry about that.
no, don't apologize. I'm just trying to make sure that it's clear because it gets convoluted. But it's not that difficult. It just, there's a lot of details, that's all. So F of C equals 1/3. Are we clear here?
Yes.
Now, we're like 90% of the way there, right?
Right.
But they asked us to find F of C. And they asked us to find C, right?
Mm-hmm.
How are we gonna do it?
It's a really good question.
Here's
Okay.
remember, I'm trying to solve this. Okay?
Okay.
Trying to solve that. How do I
Okay.
solve that equation for C?
Can we subtract by 1/3?
You could, but that would make things
A lot more
difficult.
complicated. Okay. Um,
Try doing something to get rid of the fractions or move the fraction somehow.
okay. The only thing I could think of is, but I think that'll get rid of the exponent, won't it, if you take out the c's.
How do
But
you,
I don't know.
are you talking about, are you
Yeah,
by
because we have
chance
like,
talking about hack and hack here?
no. I mean like,
Because
because
that
it's
is illegal. You do not want to do that.
no,
Bad
because
things
it's
happen when you
no, because
cancel
it's
across a minus.
well, what I meant was like, since it's c over c minus 3, can it be c over c and then c over -3? Or is that a no?
No.
Okay.
I know what you're thinking. That only applies if there's one term in the denominator.
Got it. Okay. My bad.
So if we had the fraction flipped over, you could do that.
Okay.
But
Okay.
if there's more
Good to
than
know.
one term, you can't do that.
Okay, good to know. Um,
What
the
else?
only other
What
thing,
else can we do?
the only other thing I can think of is multiplying by c plus 3 to both top and the bottom, right? Or is that also wrong?
Interesting, interesting approach. I would not have thought of that. You're talking about using the conjugates here. I don't know, but it's going to be convoluted. What if you use cross multiplication?
That
What if,
sounds a lot better.
what if I suggest to you that this is a proportion, isn't it?
Yes, yeah.
And that therefore you should use cross, or if you didn't want to think of it as cross multiplication,
Why didn't I think of that?
you could have multiplied the whole equation by 3 times c minus 3, but it's faster to just.
Can you tell that I haven't done algebra like just straight up in a
So
while?
we're gonna do 3 times c. This is gonna be 3c is equal to 1 times c minus 3, yeah?
Oh yeah.
Right?
Yes, yes.
Okay, now I think you can handle it from there.
I don't know. I couldn't figure that.
3c,
Like,
what is the right side gonna give us?
equals c minus 3.
All right, then what do we do?
Oh, great.
Don't overcomplicate your life. This is a basic linear equation. I want to get the c's on the same side. What am I going to do?
As I said, well, if you want to get the c's on the same side, don't you subtract by c?
Yes.
Okay.
So we're
Okay.
gonna.
Okay.
We had a long night last night, and I think it fried a few.
I was supposed to be able to sleep in today because my school has a thing called late start.
Okay.
But my mom had to work early and my dad had to go to work early, so I went to school
Oh my
without getting
goodness.
my sleep in.
Oh, that's okay. I did too. So I appreciate all your prayers last night for me because I ended up going to bed after midnight last night
Oh shoot.
because I stayed up with my other friend doing stuff. So yeah, so I had got like probably about 5 hours of sleep. And
That
so
sounds not fun.
I'm gonna be turning in early tonight, ladies and gentlemen.
Oh, that
Be-
sounds nice.
because I'm not gonna make it to another midnight start tonight.
That sounds no bueno.
So C here is going to be -3/2, isn't it?
Perfect. Yes. Yes.
Now, just for the sake of example, let me show you something. You see the graph that we have in front of us, right? I'm going to screenshot this. I'm going to screenshot that, but I want to add a point to our graph. So what I'm going to do is, remember last night, I showed you that you could use the graph to help you find it, right? Remember we were doing that the other night?
Yes.
So this point here should be -3/2, shouldn't it?
Yes.
So in theory, let's see where -3/2 and 3 is. Let me make sure I enter it properly, otherwise it won't tell me anything. What are you not? Oh, it thinks, yeah, it doesn't like my comma right here. It wants it at the top. So I'm gonna have to move it over and put the comma there. Okay, now you're jiving with me. Let me put this point in black, all right?
Okay.
There's my point. Let me label it here for you. Now, this point is, oh, I'm sorry, not 3, 1/3. My apologies. This is 1/3. There it is. Notice where the black point is.
Okay.
That's exactly where that f of c is equal to 1/3, isn't it?
Right.
f of c is this y coordinate. That's 1/3. Your c is negative 1.5, which is what this shows.
Got it. Okay.
Okay?
Yeah.
That's what this says. That's what this
Not too
says.
bad.
You don't have to use the graph. I just find it helpful to explain the concept. That's all.
Okay.
Okay? So remember that when you're doing, whether you're doing it for a composition or a single function, you're first showing that it applies. Okay?
Okay.
If you have domain restrictions on your function, they're not going to cause you problems unless they're in the closed interval that you're talking about.
Okay.
Does that make sense?
Yes.
So that's all of that.
Okay.
That's the whole litany on all of that. And I'm going to make us I'm going to put this in my desktop. For right now, I'm just going to put it in here. I'm going to call this IVT problem 2. And today is 08, the 30th of the month already.
Can you believe it?
Yeah, really, huh?
That's
Okay.
crazy.
All right, so now I'm gonna clear my drawings here. And I'm gonna clear the graph here, because I'm sure we're gonna need it. And I'm gonna go back to our homework here. Let's go to number 11, okay?
Okay.
So number 11, we're doing the same thing, but we're doing it with a trig graph, okay?
Got it.
Show that there is a value C with C between 0 and 2, okay? Now notice, if they tell you about there is a value of C, right?
Right.
We're gonna have to, they don't tell you, so she gave it to you a little different here, okay? Because
Okay.
notice that, what is the equation equal to this time?
4.
It's equal to 4. That's going to be my line. I want to figure out where, because that's my f of c, isn't it?
Right.
Okay, so she gave it to you a little differently here.
This
All right.
looks like a mess. Okay.
Again, don't freak out. Just do the steps. Okay. So
Okay.
let's write this down. We have 0 to 2 here, 0 C and 2 there. And our function is x squared plus cosine pi x equals 4. Okay. Now, what this represents, let's figure out what we're doing. All right. Let's figure out what the heck they're talking about. Okay. And then I'm going to compare the way this problem is worded with the way the other problem is worded.
Okay.
So whenever you have an IVT problem, you're going to have, there's a couple of things they can ask you. Okay. They can ask you if it applies and stop there. They can ask you to find a value of C and stop there. Okay.
Okay.
But you always have to show that the IVT applies before applying it. Okay.
Okay.
So there's some things that we have. We have a function or a function composition.
Okay.
We have an interval, and that interval is closed. It's a closed interval. That means that it's not infinite.
Okay.
Not infinite. The closed interval. And we have some value let me write it this way. Some output value of the function or composition. Okay? Those things will generally be given to you. Okay?
Okay.
Now, looking at, I'm going to go back to the screen share in a minute. So the function, the closed interval, and some output value of the function or composition. All right. So let's go back to the share here. And let's look at something really quick. I'm going to show you this first, because maybe this will help you on 11 here. So let me go back to number 9 for a minute. Okay. Now here, how did they give you your, okay, first of all, in number 9, do you have a function or a composition of functions?
A function, wait.
Do you have, let me ask
right?
it this way, do you have a composition? Do you have a single function? Or do you have a composition of functions?
A composition of functions.
You have a composition. This H, and this is why you have to read, okay? But this H, this is, oops, I thought I was annotating here. This H is a composition, right?
Got it. Okay. Yes.
Of this here.
Got it. Okay.
Okay. So this H is a single function, and it is the composition of these two.
Okay.
Now, what that affects is how you get the function values in the first place, right?
Right.
And it also affects a little bit the first condition. How do you show that that composition is continuous? You either show that F and G are both continuous, right? Or you show that that composition is continuous at the output value of the inner function, right? Like we said before. So it has a slightly different term. Now this function was given to you as a table, right?
Okay.
The function that we did in number 10 was given to you as in function notation, right?
Got it.
The function given to you in number 11 is given to you in an equation.
Okay.
You follow me?
For the most part, I think.
I'm going to show you the difference in the wording in a minute. Okay. But that, so we have a function there, right?
Got it.
We also have an interval. Where's the interval in number 9?
The interval in number 9 is 1 and 5, right?
1 to 5, right? Sometimes it's given to you. Look at number 10. How did she give you the interval in number 10?
In brackets.
She gave it to you in what we call interval notation, right?
Okay.
How did she give you the interval in number 9 here?
I don't know the term for it, but isn't it just
that's an inequality, right?
Okay.
So she gave it to you as an inequality with C because we were looking for the value of C. She didn't give it to you in X because she wrote, it's the same problem, Okay, but she wrote it in terms of the intermediate value theorem a little more.
Got it. Okay.
So we have a function or a composition, we have an interval, right? And then we
Yes.
have to have a value. We have to have an output value, right? An output value of my function. How did she give that to you in number 9?
She said h of c equals -2.
Yeah, I mean, she was about as blatant as you could get. There it is. H of C,
Okay.
there's my out. Now, this number, this -2 is my output value, right?
Right.
And my output values, now, my output values for the ends of my interval, okay?
Okay.
The output values, H of 1 here and H of 5, have to be, they have to enclose, or they have to be an interval in which this -2 falls in order for
Okay.
IVT to apply. So H of 1 was -4, H of 5 was 2, -2 is in this interval, so we're on the interval from 1 to 5 somewhere, right?
Right.
Now, number 10, we already know what the function is. We know what the interval is, right? What is my
Right.
output value supposed to be?
It's supposed to be -2, right?
For
Wait.
number 10?
Oh, sorry, 10. Sorry. 1/3.
1/3, right. Now, you see how it's worded slightly differently, but you always find those 3 things?
Yes.
All right, number 11 looks a little different,
Okay.
okay? It's a trig function. I'll help you solve it. Don't worry about that.
Okay.
Find the function, find the interval, and find the output value of the function. What
Okay.
is the function that we're supposed to examine?
X² plus cosine pi x.
Right. It's whatever the function is equal to over here. Now, if I had another cosine over here, then I'd drag everything to the left, make it equal to 0, maybe, right? Or
Okay.
something. But the function here is just the left-hand side. Okay. Hence, number 1 here, her function is x² plus cosine pi x. Okay.
Right.
We'll come back to the continuity in a minute. We'll get to that.
Okay.
What is my interval here?
Your interval is it's 0 to 2.
0 to 2. I'm examining it on 0 to 2, isn't it?
Right.
Now she's using the other way of writing it, 0 to 2, right?
Yes.
She's using the other way here. All right.
Okay.
If you're using interval notation, then you just write 0, 2 in brackets.
Got it. Okay.
So we've got my interval. What is my output value supposed to be? That's the hard part on this one.
4.
Right. How do I know? If you didn't have the key, how do I know that?
Because the equation is equal to 4.
Exactly.
Okay.
Now, once you find those 3 things, you do exactly the same thing that we did on 9 and 10.
Okay.
First, we have to show that the IVT applies.
Okay.
Okay. So we have x² plus cosine pi x. So here we're looking at, let me set it up this way for you. We'll graph it too, but let me set it up this way for you first. So you kind of get the idea. All right. So
Okay.
number 11, that wasn't so bad, right? It seemed like it was going to be, but it wasn't.
Not too bad.
Right? So you always look for the function. You always look for the function, the interval, and the output of the function. Yeah?
Yeah.
You need those 3 to do this. So my function here is what? You remember?
It was something cosine.
Let's go back and see.
Something cosine.
Your function is x squared plus cosine pi x.
Okay.
X squared
X
plus
squared
cosine pi
cosine
x.
pi.
So here,
What do you think? The policy, safety.
my function is x squared plus cosine pi x, right?
Hey,
Now, what is my interval? We said this before. What is it?
Sorry,
The-
Shauna. What was that?
All right,
Sorry.
what we're doing here, no, that's fine. What we're doing here is examining our problem, right? So I'm just putting down what we've already been over.
Yes.
So what I need to know is, here's my function. It's x squared plus cosine pi x, right?
Mm-hmm.
I'm gonna write it as that, all right? Now, what interval am I on? You remember?
It's what, 0 to 2?
0 to 2, let's go back and look. Here it is. C is between 0 and 2, okay?
Okay.
0 and 2. All right. So
Yep.
here we're gonna do my interval is between my interval, and I'll write it for the sake of this example, I'll write it the way they do. This is 0 less than C less than 2, right? 0 to 2. Now, what output was I supposed to get? F of C is supposed to equal 4, right?
Right.
Now, I want to first show that the IVT applies, okay? I'll show you the graph later if you really need it. I'll show it to you. But I want to show that the IVT applies. That means that the first thing I have to do is determine if the function is continuous on the interval. Okay?
Mm-hmm.
That's the first thing. So I've got this x squared, and I've got this cosine pi x function, right?
Right.
On the interval between 0 and 2. How, now, she told you that the function is everywhere continuous in the key, right?
Right.
But do you know why it's continuous?
Because the domain is not restricted.
That's a good answer. That's true. That would be one way to look at it. Okay. The other way to look at it, which I think might be a little simpler, instead of, especially when you're thinking about pi x and you're like, I wonder how that works. Think about x squared, right?
Mm-hmm.
X squared is a parabola that looks like this, more or less, right?
Okay.
Now, that is a continuous function, isn't it?
Yeah.
Cosine pi x is a graph that whatever this does, right? This pi x is going to affect the period. It's going to make these numbers whole numbers instead of multiples of pi. But we know that cosine is a continuous function, isn't it?
Right.
It's not like tangent or secant or cosecant or cotangent, right? Sine and cosine are continuous on their domains, right?
Right.
So what we can say is we know from experience that x squared is continuous. We know that cosine is continuous everywhere on its domain. And so we can say to take some of your words, which were good actually, since the function f of x has no restrictions, on its domain, the function is, I'm going to use her word, everywhere continuous. And therefore, this is overkill, continuous on the given interval, right?
What do you mean by overkill? Just the way that she wrote it?
Well, she wrote everywhere continuous, right?
Yeah.
Now, I want you to focus because I don't want you to get confused about restrictions like we
It
did on
might just
number
be
10.
it might just be because there's a language barrier,
No, but I get it.
if that's
I'm
what it
not
means.
saying, I'm saying my statement is overkill.
Oh, okay. Oh, okay.
Because if I'm saying it's everywhere continuous, right?
Yeah.
Of course it's continuous here.
Okay.
So you don't have to state this second part.
Okay.
The main reason that I stated the second part is because of number 10. If you have restrictions on the interval, right? And it's not everywhere continuous, you're not concerned about it being everywhere continuous. You're concerned about it being continuous
On the given interval.
on whatever interval is given to you.
Okay.
Okay. That's why I added that statement in.
Okay, okay.
don't-
I thought she wrote it and I was gonna say it might just because of a language barrier.
You
don't
don't
know.
need it. You don't need it, but I want to make
Okay.
sure you understand it. So continuity, we've established that.
Got it.
Now, what is the second part? Well, we have to establish that there's a sign change, don't we?
Right.
So we have to evaluate the function at the endpoints of the interval and determine if there is a sign change on either side of f of c, right? We have to decide that.
Okay.
So we're going to do that, right? So we're looking at our interval, remember, was 0 to 2. So when I plug in 0, what is f of 0? Now, this is where our trig comes in. So don't freak out. This is 0 squared, right?
Okay.
We can do 0 squared all day, every day.
Whoop, whoop.
Plus, I hope anyway, plus the cosine of pi times 0. Yeah?
Yeah.
And what does that give us?
1.
Yes.
Oh.
Congratulations. F of 0
Hey. There we
is,
go.
I'll write it out. This is 0, so you can study it later, plus the cosine of 0, because pi times 0 is 0, right?
Yep.
And I told you, if you memorize one trig fact, f of 0, cosine of 0 and sine of 0 would be helpful to you, right?
Yes.
So f of 0, you can always use the unit circle. You have to. 0 cosine of 0 is 1, so you have 0 plus 1, right?
1. Yes.
So that's 1 now, okay?
Okay.
F of 0 is 1. Now we're going to evaluate it at 2, right?
Okay.
So we're going to come over here. We're going to say, well, f of 2 is going to be 2 squared.
4. Yep. Which was-
I'm writing it out just because
Yeah,
I'm
yeah, yeah.
assuming that you're going to use this later and you might not remember why
Right.
you got the answer that you got. So I'm going to write
2
it.
squared.
Plus
Plus
cosine of pi
pi.
times 2.
Okay.
Plus cosine of pi times 2. Okay, now I'm gonna drag this over here just a tad because I need to close that. All right, so f of 2 now is 4 plus the cosine of 2 pi, right?
Right.
So this is 4 plus cosine 2 pi. Now, make me proud. What's the cosine of 2 pi?
1.
Cosine of 2 pi is 1
Wait.
because 2
Yeah,
pi
okay.
is coterminal with 0, right?
Oh, I got
Good.
scared.
No, you're okay. You you didn't do anything wrong. F
Oh,
you,
no, I'm just
ah,
no, because yeah, a couple days ago I was working with a kid and he was like, okay, cosine 2 pi, and I was like, and I got it wrong, and he was like, you're wrong. I go, no, and he goes, yeah, and he pulled up a unit circle. I'm like, oh, I'll get there. I'll get there.
F of 2 is what?
5.
Now, here's the thing, okay? This might be slightly confusing to you because we're not doing roots here, okay? Notice that these are both positive, okay?
Uh-huh.
That's okay, we're not doing a root. What are we looking for? F of C is supposed to be what?
4.
4. If we were looking for a root, it would be 0 here.
Okay.
Okay. Now, the question you should ask, and that's why I phrased it this way, is the values that you get, do they bound f of c? In other words, the question that you ask is f of c between the outputs?
Okay.
Is f
It
of
is,
c
right?
between the outputs? And it is. 4 is between 1 and 5, right?
I have a question. If f of c was 0, would you be able to do the thing? Like do
No,
this?
that's what I just
Okay.
told you. If
Okay. Sorry.
if the equation, no, but that's why I wanted to point this out because that's
Okay.
another confusion that comes. Is
Got it. Okay.
when we were doing roots, we couldn't do it because when it's a root, f of c has to be 0, right?
Got it.
Is
Okay.
f of c between the outputs? Yes, it is because I'm going to write it like this. Because 1 is less than 4 is less than 5. 4 is in the interval between f of 0 and f of 2.
Uh-huh.
Okay. Now, because of everything on this screen, because of everything on the screen, we can say thus, or henceforth, or whatever, thus, the IVT apply.
Okay.
Now, do you understand everything on the screen?
Yes, I
Okay,
do.
now we're going to actually apply it
Okay.
and do what? What is it that we want to do? We want to find the value of C that gives us 4, right?
Okay.
So what we want to do now is, here's what we know, okay? So here's where this comes in, right? We're going to say, we're going to continue number 11 over here. We're going to say, so recall, right,
Uh-huh.
that since the IVT applies, we are guaranteed a value of C in the interval from 0 to 2, right? Because that's what we tested. In the interval from 0 to 2, we tested the interval from 0 to 2, right?
Mm-hmm.
We're testing the interval here. We're guaranteed a value in the interval from 0 to 2 such that f of C is equal to 4, okay?
Mm-hmm.
That's what we know, based on that whole discussion that we just had, okay? Now, what is my function? Well, my equation was the cosine. So it's x squared. It's x squared plus cosine pi x is equal to 4, right?
Uh-huh.
Now, and I know that the solution is in the interval from 0 to 2, okay?
Uh-huh.
That's what I know. Now, I don't know where it is, but I know it's somewhere there, okay?
Okay.
Now we have to solve this equation. We have to solve. Now, what I'm gonna do here, and I did something with the format, but I'm gonna change this now to C, okay?
Okay.
So this is gonna be C squared. And I'm not sure that C squared. I don't think she did this step because she just went to the calculator. Now, why did she go to the calculator? Do you know? Because there's a reason.
Okay. I'm not too sure.
Okay, if I try to solve this for C, right?
Uh-huh.
What kind of algebra can I do? So, oops, what kind of algebra can I do to solve for C here?
Um,
I can't.
okay.
There is no algebra. Remember last night I told you that some equations are not possible to solve algebraically?
Yeah.
This is one of them.
Okay.
If we move the C squared over, right? And we tried to use a quadratic form, we've got an X here, so this would be ugly right here.
Okay.
I mean, we might be able to use some trig and break this apart and do some things, but that's a little bit ugly there. all right?
Okay.
So you know what she's gonna have you do? She's gonna
Put
have
it
you graph it.
Okay.
Now, remember I said we didn't necessarily need the graph
Right.
to do this part?
Yes.
We've done every single example except for the last ones last night
Mm-hmm.
with a graph, okay? You don't need a graph to do this part,
Okay.
but I thought that it would help you to visualize it, and it did, okay?
It did a lot. Yeah.
You don't need a graph to do this part. However, I knew that when we got here, didn't occur to me initially, but it occurred to me after I looked at hers, that we were gonna have to go back to the graph anyway to get
Okay.
this answer. So I didn't want to
Okay.
spend a whole bunch of time staring at it
Uh,
when we were gonna go back to it to get the answer anyway.
okay.
So what we're gonna do is go back and graph it and get the answer. Now I can put it on the calculator, or I can put it on Desmos.
Okay.
So which would you prefer to see?
The graph.
Would you like me to do it on the calculator?
Yeah. Yes, please.
Okay, sure. So we can pull up the emulator here. And I'll have to reshare my screen after the emulator opens, I think.
Okay, Maggie will tell me that. Maggie will give you directions to go wherever Lynn's office is about.
Let me get rid of this because that was all stats. Let me make sure I'm sharing the screen. I am, but not the screen I want. So let me go here. So what I'm going to do is I'm going to put y equals, just like always. And I'm make sure now, important consideration here.
Okay.
Your graph, your equation is in radians, yes? Cosine pi.
Yeah. Yeah.
Make sure.
My mom's talking in the background.
Make sure that your mode is in radian for this.
Okay.
If you're in degrees, you're gonna get a funky looking graph.
Okay.
Okay, make sure you're in radians when you do it. So take a quick look, make sure you're there. Now go to y equals here. Put in x squared, you know how to do that. There it is.
Okay.
Plus, this is cosine. Cosine is in the middle of your pi. You know where pi is. It's on top of the caret below the clear key in blue. Second, pi,
Okay.
x.
Okay,
Like
she's
so.
calling me back. I'm not gonna talk to her. You talk to her. Call me back.
Now, make sure that your window setting, I have to change it because I was doing some stuff. I'm gonna go ahead and remember we're looking at the interval from 0 to 2. So I'm gonna change this I'm gonna change it to slightly wider than slightly wider than what I'm trying to look at, right?
Okay.
So I'm gonna go from -1 to 3, for example, right? 50, I don't need 50, but I'll put it at, I'm gonna scale this unit at, let's say 0.5, all right? My minimum, I'm gonna do maybe like negative, let's do -10. I probably don't need that many. And 10 with a y scale of 0.5. And I'm gonna graph. And I'm gonna get this thing here, okay?
Okay. Yeah.
There's my graph, okay? Now, I'm not looking for the root, okay? I'm
Okay.
looking for it to be 4, remember?
Yes.
So what I'm gonna do is I'm gonna graph a second line here at 4. Now there's different ways to do this. This is how I'm gonna do it. I'm
Okay.
gonna do it the way, so I put it at 4 here, right?
Yeah.
Now, if these two things are equal, right, then I find the solution, don't I?
Yes.
You see that? You see
Uh-huh.
where they cross?
Yes.
Now, there's a couple things you can do. I'm gonna show you a little trick. You can trace this, okay, and approximate that way. But there's also a function that will calculate that. So what we're gonna
Okay.
do is we're gonna go to, I have to find it first. Look above the trace key.
Okay.
It says calc. You see that?
Yeah.
We're gonna go there. We're gonna use the second key. We're gonna go calc.
Okay.
We would like to calculate the intersection of those two graphs, number 5 for me. Okay.
Okay.
Make sure, now you're gonna see a little cursor that looks like it's blinking at you, right? Make
Mhm.
sure that it's somewhere on the cosine looking curve. Okay.
Okay.
And then since it is, hit enter there.
Okay.
Make sure now it says second curve. Make sure that your cursor is sitting on the second curve, the line, somewhere
Okay.
on the line. Okay. You
Okay.
don't have to guess. I just always hit enter and continue. See, it went
Oh,
right
cool.
to the intersection right here, right?
Yeah.
And there's my intersection, 1.79104441.
Okay.
And that's where that's my value of C,
Okay.
okay?
Very cool. Okay. Oh, I love learning how to use a calculator.
Your calculator is your friend.
Until they give you a no calculator portion.
But that just means they're confident that you can do it without it. Now,
Yeah.
all right.
Oh.
So I'm gonna let you, there's 2 problems left.
Perfect.
I'll do them with you if you want, okay?
Okay.
But now read 12. Read 12.
Okay.
Those bills you do.
Does the IVT apply to the function h of x equals x squared plus x over x minus 2 on the interval 2.55? If so, find the value of c guaranteed to exist such that h of c equals 12.
Mm-hmm.
Okay.
So now, all right, so I'm gonna, h of x is x squared plus x,
I think
right?
Mom has it. If she doesn't have
Uh-huh.
it, let me know by
H of
tomorrow.
x, I have to cheat and
But she has it.
write this down because I don't wanna. Are you able to annotate on my screen if I give
When
you
I got in my car, I said,
have
Mom.
something to annotate with?
Paper.
Like this?
And it's one bit, it's that look, it looks to me
Yeah,
like it's
okay, you can annotate,
one
that
big
works.
form.
H of
Really
x
cool.
is equal to x squared plus x over
Whatever
x
name is
minus
after
2
the cell phone. And then he goes, oh, okay. And then she gives
on
me
the interval
in
from
case she
2.5
gives me a copy. And I go, okay, she gives me 2 copies.
to 5. And we want to find if it applies, h of c
Fine.
is 12. Now, okay, so I'm gonna say that. Now, I'm gonna, this is 12 now. So we're gonna say this is 12 here, okay?
Okay.
Now, you do it any way you want, okay?
Okay.
But I want you to see if you can do this on your own, okay?
Okay.
I'll help you if you get stuck.
Okay.
Remember, there's 2 parts.
Got it.
Does the IVT apply
Okay.
That's the first thing you need to do.
Okay.
And then I'll give you another whiteboard over here. And secondly, the second part of this is if the IVT applies, find C such that f of C, or H, I think it was H of C is 12, okay? Now I'll give you a hint because you've seen the key already. You should find that the IVT does apply here, okay?
Okay.
But you have to show me why.
Okay.
So tell me, so write it out and tell me how
Yeah.
you would do
Let me. Okay. So. Oh, this is new. Oh, this is not fun. Okay, so we have HF. I'm just gonna write out
it. Yeah,
the
take your
equation.
time. I'm gonna turn my light on because I have my
Huh?
blinds closed to keep the heat out, and it's getting dark, like it's 8 o'clock at night in here.
Oh, really?
Yeah, because there's like the sun is not facing this side of my room anymore. So the it's lower in the sky, so my room is actually pretty dark, right?
I don't know if I've told you the yearbook drama that we're going through currently, but but basically the teacher who's taking over the yearbook room is he's his own person. Just I don't know how to explain him. But he he blocked all of the light switches in the room with what are they? Bookshelves?
Oh my goodness.
Except like one, but the room has like two light switches on it. One for like the front of the class and then the other for like the back of the class.
Right.
Yeah, and he got rid of one of them. And so it was something we were discovering today because it's really dark in there because
See.
the windows are um they have stuff on top of them.
Uh-huh, yeah.
So it's a new journey. Okay.
Y'all gonna bring flashlights to class.
I know. Well, it's also his colors that he's picked are also really dark.
Oh my goodness, okay.
Yeah, and then he
You're
has,
like in the white room with black curtains, right?
yeah, it's creepy in there now.
I can imagine.
And that because it used to be it's funny because it used to be the complete opposite. It used to be like bright and colorful and like the teacher had a color scheme of like just beige, not beige, but like a cream color.
Right.
And so it's a lot different than his black and brown items. And then he has a chair. Don't get me started about his chair. It in itself is a safety hazard. Okay.
For himself, right?
Well, it's just it's ripping apart. It's like ripped apart.
Oh my
It
goodness.
it is an adventure.
So tell me something about the problem that we're doing here. I see that you're
Okay.
writing some stuff.
Okay. Ooh, what am I doing? Okay. Oh, that's not fun. I didn't realize I was gonna do that. Okay. Okay. So you do 2.5 raised to the second power.
Well, wait a minute, before you can do that,
Am I allowed to do that? Oh no, wait. Isn't it
what's the
F?
first condition? You're on there, you're on the right track, but the first condition is not that.
Oh, we have an asymptote, don't
So
we?
you have to show me, you have to show that the function is continuous on the interval. You have to state why that is, right? Now this is why I wanted you to do this, right? So,
Okay.
so here's the thing, h of x, and I actually think it's lowercase, h of x,
Oops.
Okay, tell them.
h
Okay.
of x has a vertical asymptote at x equals 2
Okay.
and is undefined there, right?
Right.
This
Okay.
goes back to your question about number 10. That's why I wanted you to do this. Is undefined at that point. However, however, okay, x equals 2 is not
In the interval.
in the given interval.
Okay.
On the given interval, h of x is continuous. That's the first part. The second part of this is evaluate h of x at each endpoint of the interval and decide if 12 is in the interval defined by the outputs.
Okay.
So h of 2.5 and h of 5. Okay,
Okay.
take it from there.
Okay. Let me click the drop or not. I'm going to click the text because that's a little bit easier. Okay. So it goes. All right. Okay. So it goes 2.5 raised to the second power plus 2.5. And that's over. Oops. Okay.
Yeah, you're okay. That's okay.
And
Over
it's
2.5 minus 2.
2.5 minus 2. Okay. And so
When you evaluate that,
2.5.
let's use the key and use that.
Okay.
That's it. So when she evaluated, she got 17.5.
Okay.
Okay.
Got it.
I know you can evaluate that. I'm just trying to save you a little bit of time.
No, yeah, it's perfect.
So this
Much appreciated.
is 17.5, right?
Right.
This is 17.5.
Yep.
Now what is h of 5? Well, it's 5 squared. So we're gonna do 5 squared plus 5 over 5 minus 2. Okay?
Yep.
That's gonna be 30 over 3, which is
10.
Now, the question you should ask is, is 12. Remember, my output is 12, the output that I want in the interval from 10 to 17.5. Is 12 in there?
Yes.
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 So the IVT applies since actually let me write before I do that. 10 is less than 12 is less than 17.5, right?
Mm-hmm.
Since the function is continuous on the interval, on move it down some. Here we go. On the interval and f of h of 5 is less than 12 is less than h of 2.5. Okay, so
Mm-hmm.
we know that to be true, right?
Right.
Move this over. Okay, there we go. Right? So
Yes.
now I can go to the next whiteboard and I can say that since that's true, I can find my value, right?
Yes.
So I'm going to say 12 is equal to my function is c squared plus c over c minus 2. So
Mhm.
now this is, remember this changes to c at this point, c squared
Okay.
plus c because this is f of c, right?
Right.
Over c minus 2. Now, how do we solve that?
Okay. Can you just
Very
multiply?
carefully, right?
Yeah, very carefully. Can't you just, because 12 is over 1, can't you just multiply, like, like 12 with c minus 2 and 1 with c
Yeah.
squared plus c?
Yeah, so
Oh.
don't overcomplicate your life. This is c squared plus c, and the other side of it is going to be 12. This is going to be 12 times c minus 2. Right?
Mm-hmm.
Now, what am I going to do with this is c minus 2, right?
Yep.
So now, what do I do now?
Distribute.
Yeah, so this side is going to give me 12c minus 24, right?
Mhm.
And this side is going to be, this is going to be c squared c squared plus c, right?
Right.
Like so. Now what?
Can't you set, well, I mean, this might be skipping a little bit, but can't you just set it to 0 by
Yes,
subtracting negative
so
12c and
c squared, what we're gonna do, we're gonna do exactly what you said. So we're gonna say c squared. And I'll even skip another step. If I have this c and I bring over 12c, I get negative 12. So negative 12 plus c is gonna be negative 11, right? So I'm gonna have c squared minus 11c plus 24. Watch out for that. Plus
Right.
24 is equal to 0, yeah?
Yes.
Now, what can I do from here?
You can, what's the word for it? Is it
It's
like
the word that starts with an F, ends with an R.
ends with an R? So I mean, in my head, I'm like, you can break it up, but I don't know what the actual correct
It's
terminology is.
called factoring there.
Factoring. Okay.
So,
Really bad at vocab. Really bad.
so,
I
what
just
are,
never had a math vocab test, you know?
what are we gonna do to factor this thing?
Okay. Wouldn't it be okay, well, you know that C times C is gonna be C squared, so it's C, and then to get to 24,
Factors of 24 that give you 11.
isn't it 8
Mm-hmm.
and 3?
Yes,
All right, negative 8 and negative 3.
that wasn't so bad, yeah?
No, not too bad, not too bad.
Now, okay, what do we do from here?
Oh, okay, so you're gonna set C equal to 8 and C equal to 3,
Uh-huh.
and then you have to figure out which one is in between your interval.
Very good. Which interval are we looking at?
Are we, oh goodness, what are the numbers? There's so many numbers now. 2.5 and 5.
Yeah, 2.5
Okay.
and 5. Very good.
And so the only one that could be in between it is 3.
So because, I'll write you a note. Because the interval is 2.5 to 5, right?
Mhm.
2.5 to 5. The value of C is which one?
3.
Beautiful. You did it.
Boom.
That's
Okay.
it.
Oh,
That's it.
not too bad. Okay.
So how did you do it? Think about how you did it.
Okay. So we first had to figure out if the interval was continuous, and we had to prove
If the
that.
function is
Or
continuous.
sorry, the function is continuous,
Mm-hmm.
which it wasn't because it had a horizontal asymptote, but it did not affect the interval because the asymptote was not in between 2.5 and 5.
Mm-hmm. So just be a little more precise. We're not, you have to show that
Okay.
the function is continuous on the interval that's given.
Got it. Okay.
This function wasn't continuous everywhere, but it is continuous on the interval that's given to you.
Right, because the asymptote was at 2 and 2 is not in between the interval.
Right. Right.
Whew.
The next part of what you have to do is evaluate the function at the endpoints of the interval
Right.
and make sure that the output that you're trying to test, we're trying to test 12 here, right?
Right.
Make sure that the output that you want to test is in the interval of the outputs that you get,
Right.
10 and 17 and a half. As long as that's true, the IVT applies, and then you just set the equation equal to the value and solve it.
Got it. Okay.
Okay? All right.
Yes.
So you have, I think you have one more problem left,
Okay.
don't you?
Yes, I think so.
There's one more left.
Number 13.
So, yep, and then we'll be done with our homework, right?
Yes. Yeah.
Okay. So this is an exponential function. Okay.
Okay.
So f of x is equal to -1/2 to the power of 3 minus x minus 3 on the interval from 2 to 5, where f of c is -4. Does the IVT apply?
Whoa. Okay.
Actually, with her directions, you would have stopped there. Does the IVT apply? But she went on to find the C for you. Does the IVT apply? Let's find out.
Okay.
Are we continuous? You can go ahead and write that statement, okay, for number 1 there. F of
Okay.
x is continuous on the interval because exponential functions are continuous over all reals.
Okay.
Okay,
Okay.
all right. Now, the second part of proving continuity, I'm sorry, of showing that the IVT applies, right,
Mm-hmm.
is to evaluate your output. So go ahead and evaluate it.
Okay.
F of 2 and F of 5.
F of 2 and F of 5. Okay.
He just basically gives you the final answer, but you need to like, so
Okay.
you could see it.
Okay.
Remember, you're evaluating the function -1/2 to the power of 3 minus x.
Okay.
Okay.
Okay. Hold on a second.
I have to take Vital still, so I'm gonna do that while you're doing this.
Okay.
Thank you, help done.
How are you doing with those evaluations?
I'm just I just got it written down on paper because I just put it on paper.
Okay,
But
that's fine. But you should be able to do them. Are you having any trouble?
no, not right now.
Okay, that's good.
For now. For
That's
now.
good. No, I think you've got the idea. This is not that
It's not impossible.
We put in a lot of work on it, so I think it should be fairly smooth from here.
Wait. I'm looking, I might, or maybe I'm just. Oh, that's what it is.
You need me to plug it in, or are you okay?
No, I accidentally wrote down negative parentheses -1/2.
Oh, yeah, that could be,
That'll be an issue.
give you a
Um,
different number, right?
Yeah. 3 cents. Okay. I got them. Did you want me to do the C2?
Yeah, so now you can say that it applies why?
Okay. It applies because C is in between -3.5 and -7.
Not C, but F of C.
Oh, F of C. Okay, F of C.
The F of C up here, this is not a C value. This is
Okay.
F of C. See that?
Uh-huh.
So is F of C between these numbers? It is, isn't it?
Okay.
So so remember how showing that it applies has two parts, right?
Right.
This is the first part, this is the second part.
Okay.
This statement, what I've been writing is this. What I've been writing in between here is after this, I would have said, so since the function is continuous on the interval and and then I would have written what she wrote here. -3.5 is less than -4. This should actually be going, wait a minute. Wait a second. I think she's got her inequality signs going the wrong way. Give me a second here.
Yeah, it looked like they were going the wrong way.
-3.5. -4. No, you know what? Her interval is backwards. That's what it is. Because -7 is the smallest. So
Okay.
she's okay, but her interval is backwards. So these numbers are fine, okay? But what I would do is I would write this. I would say this. I would say that you had, so if you look at the number line, let me do this. Let me show you this really quick so that it makes sense to you. Here's
Okay.
0, right? There's 0.
Yes.
There's -1. Okay. -4 is over here. Right? -7 is over here. Okay.
Okay.
Now your interval was like negative, what did she say? -3.5?
Yes.
So one of your answers was -3.5, which is about there, right?
Okay. Yeah.
And the other one was here, right?
Yes.
So -4 is in this interval, isn't it?
Yeah.
So she's right, but she wrote the interval backwards. So what she should have written was this. She should have said -7, because that's the smallest, is less than -4, like this. Is less than -3.5. Now, what she did, that's what you're used to seeing. Okay?
Okay.
That's what you're used to. It's not wrong to turn this around, and that's what she did. But she's just never done that in any other
Okay.
problem that she's written. If I read this going the other way, right, then I get -3.5, right?
Yes.
Greater, it is greater than -4, because it's not as negative, is it? See?
Oh, okay.
-5 is less negative than -4. So -3.5 is actually larger because it's closer to 0, right? And -4 is greater than -7. It's just that she's never written it like that
Oh, okay.
in the key, but usually by convention, we write it with the smallest number first.
Okay.
And that's what she's done on every other problem. But this is not a wrong inequality here, okay?
Okay.
It's just not something that she's been writing. And we normally write between statements with the arrows going to the left, not the right,
Okay.
okay?
Yeah.
So now because of that, the IVT applies, right? And now you can actually apply it. So you can
Okay.
actually go to the problem itself. So here's your function, right?
Yes.
-1/2 to the to 3 minus c. Remember, it changes to c because this is f of c, right?
Right.
So -1/2 to the 3 minus c minus 3 equals -4. Solve the equation.
Oh, lovely.
Okay. Start by adding 3 to both sides. Start by adding 3 to both sides.
Okay.
Okay.
Uh-huh.
So -1/2 to the 3 minus c is -1.
Right.
Now, what she did here next was this negative, okay? This negative is on the outside. So she said, I'm going to make my life easier by making my equation positive, all right? So what she did
Okay.
is she multiplied both sides by -1, okay? That gave her 1/2 to the 3 minus c power equals +1.
Okay.
Are you good there so far?
Yes. Yeah.
Now from here, this c is in an exponent, so we have to use logarithms to
Okay.
bring it down. So what we do is we bring down the exponent, 3 minus c, and you need parentheses here. 3 minus
Okay.
c times the log of 1/2, which is the base,
Okay.
is equal to the log of 1. Okay.
Okay.
Now, then you take 3 minus c times the log of 1/2 is equal to 0.
Okay.
Okay. From there, what she did was she made her life easier by getting rid of the log of 1/2. She divided both sides by the log. Okay. Normally, that's not something that we would do, but you have a 0 over here because the log of 1 is 0. Okay.
Okay.
So it made her life considerably easier than if she had distributed and evaluated and did all that.
Uh-huh.
Okay.
Got it.
So 3 minus c, then. Remember, this is not 0, this is 1. They cancel out. This is a fraction, right? So this is 3 minus c is equal to 0, 0 because the log of 1 is 0. And so 0 over anything is going to give us 0 other than 0, obviously, right? And so c is equal to 3. But now you have an additional step because of the type of equation this is.
Okay.
Because you just used logs,
Uh-oh.
you have to make sure that your value of c fits back in your exponential function. Does it actually work?
Okay.
So what she does is she does a quick check. Log of, so she says, log of, wait, what is she doing here? Oh, okay. She she did a shortcut. It threw me off for a second. But she wrote 1/2 as 0.5. Okay.
Okay.
I'm not sure why she has 5 there. I'm really not. I don't know why she has 5.
Why does Miss McNatt do math? No, just sometimes her keys are like this.
No, I don't know why she did. Log 5. 3 minus c. I'm not, okay, wait a second. Let me stare at it for a minute. Log 0.5. Oh. Okay, she plugged it into, okay. She plugged it in, she didn't plug it into the original. That was just what I would have done. She didn't plug it in here. I'm sorry, she didn't plug it in here. She didn't plug it in here. She plugged it into this version. Right here.
Okay.
She plugged it into that.
Oh,
She plugged it in after she took the log of it.
is there a reason for that?
So let me show you something. So my equation is She got a value and it was 3, right?
Yes.
And my equation is -1/2 to the 3 minus x is -3. Okay, so I'm looking to check. Yeah, I'm gonna go through this one because I understand what it's the way she's writing it. That's a little bit odd. So your equation is -1/2. So it's -1/2 to the power of 3 minus x. So here you've got three minus x. Okay. And
Mhm.
you've got -3 is equal to 4. Okay.
Okay.
Now, and she got this solution x is equal to 3, right? But
Mhm.
she did some work on this, right? Remember?
Uh-huh.
She did some work on this, and I think, oh, this is supposed to be, my apologies. This is supposed to be, I made an error here. This is supposed to be equals -4, right?
Uh-huh.
And so she moved it over and she got, this is -1/2 to the power of 3 minus x. And she moved the 3 over and got -1, right?
Yes.
Now, what she did is she made this positive, so she got 1/2 to the 3 minus x, yeah,
Yes.
equals -1. Now, what she did, remember, we're plugging in 3, but she hasn't done it because that's not the version that she plugged 3 into. What she did was
Okay.
she changes this half to 0.5.
Do you have to do that, Shauna?
No, you don't.
Couldn't you just plug in 3 into the exponent and then it'll give
Yes,
you
yes,
1 and then add it over and it's 0 equals 0?
yes.
Okay.
Okay, but I'm just explaining to you what she did because
Okay. Okay.
it threw me off when I was looking at it. This is equal to -1, right?
Yeah.
You see that? Now,
Uh-huh.
if she wants to check this, she did it from the log. So what she ended up with was she wrote this as log of this thing here. So she wrote, remember I said, why is it log of, this is why, because she picked it up from here. Log of,
Oh.
this is 3 minus x, you see?
Yeah.
And then you have, so this, I just wanted I would have plugged it in from the original, not from
Okay.
here. But I'm just showing you what she does, okay? Now,
Okay.
the thing here is that you've got, the problem with this is you've got the log of, so here, when you did this part, you see how you've got, now this negative, oh, and I think I left on a negative and I shouldn't have. Let me go back. I think I've got an extra sign. Was that supposed to be 4? Or was that supposed to, no. Was this supposed to be 4? Let me look.
It was supposed to be -4. I think.
Negative, okay, yeah. So -4. Oh, this is minus. I think I've got a sign error somewhere. I've got to find it. I think it's supposed to be a +3. Let me check. -3. Yeah, so this is -3. So this is, yeah, the problem, I can fix this part. This is supposed to be, I made a sign error. If I add 3 here, this is, okay, this is supposed to be negative. When I remove at this step here, you see it?
Yes.
This is fine, but when I multiplied, this should have been, let me show you. So that step was okay. This, when I remove the negative here, I should have had, this should equal +1. Otherwise, I'm not going to get a solution. That should equal positive. You see why?
Yes.
Because essentially so this is the same step here. This needs to be equal to +1. So this is equal to +1 here. And then this is equal to the log of 1, right? Now, what she's going to do is she's going to say that this, she puts it in C because obviously, see, I would have done it in here. She did it in her C. So this is all C. But she changes the 0.5, the half to 0.5. She puts in 3 there. So you get log of 0.5 to the 3 minus 3 now, right? And that's 0, right?
Yes.
And then you get, so essentially she gets the same thing that we do. Okay?
It's just very complicated.
But she just, yeah, she made it a little more convoluted than it needed to be, right? Because here this is equal to log of 1, right? So this is log of 0.5 to the 0 power, right?
Yes.
Well, 0.5 to the 0 power is 1, isn't it?
Yes.
So you get log of 1 is equal to log of 1. And so here, log 1. And actually, you could have stopped here because they're the same. But she went to 0 equals 0. Therefore, 3 is a solution. And the value is C equals But yeah, her check, she took it from here, but she did it in C instead of X, which I can see that. But she changed this half to 0.5 and then proceeded this way.
Oh my.
Okay. But you have my point was that here you have to verify that this solution actually works, which is what
Okay.
this was.
Got it.
But she started from this step.
Got it.
She started from here.
Okay.
Log of 0.5 right there. See it?
Uh-huh.
Log of 0.5, and then you have, actually, I take that back. She started from, my apologies. She started from this step, but she took the log of both sides. So here, she's starting from here.
Okay.
She starts from there.
Got it.
She checked it from there.
Okay.
I would have checked it from here, from the top.
Oh, I see. I see.
She started from there, but she needed a log to get this exponent down.
Okay. Do you think, okay, so that's why she used the log. Okay.
I would just, you know what I would do at this point is I would maybe copy the key and then ask her why she didn't start.
Okay. Yeah. I think I'm gonna do that because I mean, she can get the same answer from just
I just
getting
want
into it.
you to know that that's because that could throw somebody off really badly. But
Okay.
the reason you're checking it is because just because this came out doesn't guarantee that it's a solution to this.
Okay.
Okay, so you have to check that result.
Okay.
It doesn't affect the IVT, that's an algebra thing. Okay,
Okay.
what you're doing right now doesn't change the calculus at all. What you're
Okay.
establishing that algebraically there is an answer. That's what you're saying. That's what
Okay.
you're establishing.
Okay. Cause I was gonna say that definitely would have thrown me off if I had done this.
No, and it did too. I was looking at it like, where did she go? I mean, I knew what she was doing, but it was like, where did you go, Pam?
Where did you come from? Where did you go? Happen now, Joe.
Yeah, I get you there. So I'm gonna go ahead and
Okay.
start recording.